Hey guys, so the last couple days we've been looking at our multiplication rule, but with our independent values. So what we're talking about is you're picking something up, but then you put it back in, which when we looked at that, the denominators or the bottom of the fractions did not change. Today, we're going to look at it when we pick it up and we decide to keep it. So then that denominator, that total, might change as we're decreasing. A couple things to remember. And in both, when you see those words, that is telling us that you need to multiply. Okay, there is one more word that could mean and or both, and that's when you see all. If they're all this, that means I want the same thing each time. So if I'm picking up all Snickers, I want a Snicker and then a Snicker. Okay, however many times it's asking for. So before, again, we were talking about independent results. The result of the first event did not impact the second one. This time, the result of the first event is going to impact the second one because I'm not going to put it back. So the denominators, or the total, the bottom, remember, is my total. The denominators do change for this. And how I know that is that keyword you're going to see without replacement. Without replacement. Or something similar. Does not put back. All right, let's go ahead and look at this first one. Miss Lee is picking an energy drink for the day. It's going to be a long day, so she needs one for the morning and one for the afternoon. She reaches into the fridge that has 3 Monsters, 2 Celsius, and 2 Alani Nu. What is the probability she grabs a Monster and then a Celsius? Okay, so I see this statement here. She reaches into the fridge that has 3 Monsters, 2 Celsius, and 2 Alani Nu. And what that tells me is the total right away. In that fridge right now, I have 7 total. Okay. She needs one for the morning and one for the afternoon. So she needs 2 energy drinks. And we're going to assume that what happens is she's going to drink the one in the morning and then drink the one in the afternoon. So she's not going to pick it up and put it back into the fridge. She's going to pick it up and drink it, and then she's going to go back in later. So what we're going to look at here is the first probability that she gets a Monster. And the second one that she gets a Celsius. So probability of a Monster. Well, I have 3 Monsters out of the 7 total in that fridge. So she picked it up and she got a Monster and she drank it. So my total is no longer 7. She picked one up and drank it, so now there's only 6 left in there. But remember, she picked up a Monster. So now I'm curious on how many Celsius are left. So in this situation, there's still 2 Celsius in there. At this point, we're going to multiply straight across. So I'm going to do 3 times 2, which is going to give me 6, and then 7 times 6, which is going to give me 42. That process is still going to stay the same. And then we're going to go ahead and we're going to divide. So 6 divided by 42, when I plug that in, I get 0.143. We're going to look at that third number, and that third number is going to tell me if that second one goes up or stays the same. So in this situation, a 3 is less than 5, so it's going to tell that 4 it needs to stay the same. So my answer is going to be 0.14. Let's look at number 2. What's the probability of picking 3 cards, all black cards, from a standard deck of cards without replacement? Okay, well, I automatically know my total. Anytime I'm talking about a deck of cards, I know I have 52 total. Now I got to figure out how many fractions I need. How many cards am I going to be picking up? It tells me I'm picking up 3, so I'm going to need 3 separate fractions. Now, I want a black card, and then a black card. So when I'm doing this fraction, the first one I'm looking at is originally from this deck of cards before anybody touches it. What's the probability of getting a black card? I know there's 52 total. And of those 52, 26 of them are black. We are going to say I picked up a black card and I put it in my back pocket. I'm not putting it back in that deck of cards. So I have to figure out, well, how many black cards are left in that deck? Well, right now there's 25 left. And then how many total? Well, there were 52, but I took one. So now there's only 51. I picked up another black card that second round, and I put it in my back pocket. So now I have 2 black cards in my back pocket. The probability of getting a third one, well, it's one less than the 25. And my total, there are only 50 to choose from. So I'm going to go ahead and I'm going to multiply the top. 26 times 25 times 24. I get 15,600. And then 52 times 51 times 50. I get 32,600. We can go ahead and we can divide that out. And I get 0.118. So I'm going to look at that third number. That third number is going to tell me what to do with that second one. Okay, in this situation, since it's a 5 or more, it's going to tell that one it needs to increase. All the other ones are going to stay the exact same, but that one is going to increase. Once that happened, that 8 did its job, so it's disappearing and it's gone. All right, number 3, in a shipment of 20 iPads, 4 of them are defective. Okay, well, that statement right there just told me I have 20 total iPads. 3 iPads are randomly selected. That right there is telling me how many times I'm grabbing these. So there's going to be 3 fragments. What is the probability that all 3 are defective if none of them are put back? We're not putting them back. Okay, so I want a bad one, a bad one, and a bad one. All right, probability of getting a defective iPad. Well, there's 4 defective ones out of 20 total iPads. I picked up a defective one, and I put it away. The probability of now getting a defective one again is going to be, there's only 3 of them left, and there's only 19 iPads left. So I picked up another defective one that time, and I put it away. So the probability of getting another bad one or another defective one, there's only 2 left in that pile. And in that pile, there was only 18 total. So let's go ahead and multiply 4 times 3 times 2. I get 24. 20 times 19 times 18. I get 6,840. At this point, I can go ahead and divide. And it's going to be 0.004. Now, this is one of those special situations. This 4 is going to tell that 0 to stay the same, but I don't want a probability of 0.00. So we're actually going to leave it as 3 decimal places for this one. All right, on to number 4. Find the probability of drawing a queen, an ace, and then a 4 from a standard deck of cards without putting any of them back. Okay, deck of cards, I know I have 52 total. The amount of cards I'm picking up are going to be 3. The first one I want is a queen. The second one I want is an ace. The third one I want is a 4. And we are not putting them back without putting any of the cards back. So I'm going to keep them once I pick them up. All right, so queens. Before I touch any of that deck, there are 4 queens out of 52 cards. I picked up a queen and I put it in my back pocket. Now, aces, there's still 4 aces left. I didn't pick up an ace. I picked up a queen. But there's not 52 cards because I took one and I put it in my back pocket. So there's 51. I picked up an ace that second time and I put it in my back pocket. So now I have a queen and an ace in my back pocket. 4s is what I want last. Well, there's still 4 4s, but now there's only 50 cards left. So we're going to do 4 times 4 times 4. 64. 52 times 51 times 50 is 132,600. Divide those out. Again, this is going to be a very special situation. It's going to say 0.0004. Normally, we only write 3 down and then round to the second. But the problem that I have here is that would be all zeros. And I don't want that. I need to show some number here. So we're going to write until we get to one of our first numbers. Couple more left here. Number 5. There are 12 candies in a bowl. 4 are Kit Kats, 3 are Snickers, and 5 are Reese's. I know my total is 12. Okay. We want to find the probability that Miss Meyer draws a Kit Kat, eats it, and then draws a Reese's. So she's going in for that bowl 2 different times. The first time she wants a Kit Kat, and the second time she wants a Reese's. All right, so before I go in at all, the probability of getting a Kit Kat, there's 4 of them out of 12 total in that bowl. She ate that Kit Kat. She got that Kit Kat. She ate it. So now when I go back into that bowl, there's only 11 total candies in there. But of those 11, I still have 5 Reese's because I ate a Kit Kat the first time, not a Reese's. 4 times 5 is 20. 12 times 11, 132. Divide those out. 20 divided by 132 gives me 0.152. I'm going to look at that third number. That third number is going to tell me what the second one does. Because it's less than 5, it's going to tell me everything is going to stay the same. But once it says that, it disappears because it did its job. Okay, last but not least here. You and your friends are going on a road trip, so you pack a cooler for everyone. You fill the cooler with 12 Gatorades, 10 Cokes, and 13 waters. Okay, so what's that telling me is I have 12 plus 10 plus 13. I'm going to have 35 total in that cooler. 35 drinks in that cooler. 12 Gatorades, 10 Cokes, and 13 waters. You reach in and you pull out 3 beverages. What's the probability that you pick a Coke, and a water? 2 Cokes and a water. Okay, so I'm doing 3 beverages where I get a Coke, and then a water. Okay, before anything happens, the probability of getting a Coke. Well, there were 10 of them out of the 35 total in the cooler. I reached in and I took a Coke out. So how many Cokes are left in that cooler? Well, there's only 9 left now. And there's only 34 total drinks in that cooler. I reached in a third time and I grabbed I reached in that second time and I got a Coke. So now I've taken 2 Cokes out. Probability of getting a water now. Well, I know there's only 33 left in the cooler. And of those 33 total, 13 of them are still waters because I didn't pull any of those out. I only pulled Cokes out. So 10 times 9 times 13, 1,170 divided by 35 times 34 times 33, 39,270. I'm going to end up with 0.029. This 9 is going to tell that 2, hey, I'm 5 or more, so I need you to head up 1. So 0.03. It did its job, and then it disappears. All right. Good luck. Reach out if you have any questions.